Hello, welcome back to our channel. Today we are going to discuss about work energy power. It is very important topic for both mains, MSET as usual for NEET, and sometimes we are expecting two questions for the NEET and for MSET also. Listen carefully. Anyway, we can start this one with first scalar product. You know that there are two types of multiplications are there for vectors. One is the scalar product, another one is the vector product. In this chapter we can focus only on scalar product. This is called the dot product also. Scalar product or dot product. See, P bar dot Q bar equals to mod of P bar, mod of Q bar, and cosine of the angle between them is called the scalar product. This is the formula for scalar product. Okay, and it obeys the commutative law, it obeys the distributive law, and you should remember that I cap, j cap, k cap are the unit vectors along the x-axis, y-axis and z-axis. K cap. This is the j cap. Okay. Then here I cap dot I cap equals to j cap dot j cap equals to k cap dot k cap equals to 1. Y angle between them is theta equals to 0, and that too these are the unit vectors, means magnitude equals to 1. And one more thing, I cap dot j cap dot k cap dot I cap is equals to 0. Why? Here theta equals to 90 degrees. From this what you are understanding, if any two vectors are perpendicular to each other, dot product is equals to 0. Then from this cos theta equals to P bar dot Q bar by mod of P bar mod of Q bar. So these formulas are there for the scalar product. And what are the examples for the scalar product? Work done equals to dot product of force and displacement. Power equals to, power is also scalar, F bar dot V bar. These are the examples. We do one problem. If F bar equals to 2I cap plus J cap plus K cap, then displacement is I cap minus J cap plus K cap. Find the work done, means just we can do the dot product. 2 into 1, 2. I cap dot I cap is 1. I cap dot J is and I cap dot K is, other things becomes to 0. Here plus into minus, minus only 1. Plus into plus, plus 1 you are getting. So finally here work done is how much? This is the 1 joule. Like that we should calculate. Like that here how to find out the cos theta? Cos theta, suppose if P bar equals to 2I cap plus 3J cap minus 4K cap. Then Q bar equals to I cap plus 4J cap minus 2K cap. Find the cos theta, means we can go through the dot product of this one. 2 plus 12 plus 8 divided by under root magnitude of first one. 4 plus 2 square plus 3 square is the 9 plus 4 square is the 16, and here under root 1 plus 16 minus 2 whole square is the 4. After simplification, cos theta is how much? This is the 22 by under root 29 plus under root 21. Like that we can find out the angle also. And one more problem we can discuss here. If P bar equals to I cap plus 2J cap plus 3K cap, then Q bar equals to I cap plus NJ cap plus 4K cap plus 4K cap. Otherwise you can take it, this is minus 4. So here theta, both are perpendicular to each other. Find n value. How to find out the n value here? If two vectors are perpendicular to each other, dot product equals to 0. So this dot product P bar dot Q bar is equals to how much? Here 1 plus 2n minus 12 is equals to 0. Then 2n equals to how much? 11. Then n value equals to 11 by 2. So 5.5. 5.2. Like that we can find out the, if you don't know the n value, we can find out the cos theta. And any two vectors, you know that you can able to find out the force when you work done, when you know the force and displacement, and we can find out the force and power also when you know the force and velocity. So these are belongs to scalar product. Like that we can go through the few more formulas based on this. Component of P bar along the q bar, component of the p bar along the q bar means you can take it component of p bar along q bar means what we want. P cos theta is how much? P bar dot q bar by mod of q bar, like that. So like that, component of q bar along p bar, you can take it q cos theta equals to p bar dot q bar by mod of p bar. So you must remember these formulas to do the scalar product. Then come to work done. In our chapter name, first we have to go through the work, then we are going to the energy, and last one is the power. Look, what is the work? Suppose one body is there, it is placed on the surface. This body mass is m. We are applying the forces like this. Because of that reason, this displacement is s. It makes an angle theta. Just now we know that work done. What is that? See, here f is the vector. It is resolved into two components. This is f sin theta, and this is how much? F cos theta. But there is no movement vertically. We should consider horizontally. How many forces, which force is acting for f cos theta and displacement. So work done equals to force into displacement, but instead of force, f cos theta into s. Finally, it should be right f bar dot s bar also. Suppose if theta equals to 0 degrees means like this, we can take it. This is the mass of the body. We should apply that. Displacement is 0, cos 0 equals to 1. Simply we can get it. W equals to fs also. And we should remember that it is a scalar quantity, and its unit is the joules in SI system, then ergs in CGS system. 1 joule equals to 10 to the power of 7 ergs, and 1 erg equals to 10 to the power of minus 7 joules. So you should remember all these values. This is belongs to the work done. Now we can go through the when work is positive and when work is negative. See, if theta is in between 0 degrees and 90 degrees, you can say that work is positive. Like that, if theta is in between 90 degrees and 180 degrees, what we are saying, work is negative. Work is negative. Like that, when work done is equals to 0, first condition is if theta equals to 90 degrees, any person is carrying the suitcase on his head. See, that force is, gravitational force is acting downwards and he is going like that. So in this case, look here, the person is moving like this. Gravitational force is acting downwards. Here theta is how much? 90 degrees. So in this case, work done is 0. Like that, one person is standing, one force is acting like this, another force is acting like this. Here resultant force equals to 0. At that time also work done is equals to 0. And third case, you are making the rotation around this college. One rotation means displacement is how much? Displacement is 0. So work done is also 0. So if theta is 90 degrees and the displacement is 0 and force is 0, in all these cases work done is equals to 0. Suppose for small work done, we should write this expression also. dW equals to F dx also. Force into displacement. From this you are writing F equals to dW by dx also. So when you want to find out the work done, we can go through the integration. Integration of dW equals to integration of F dx. Differentiation, this one is cancelled. Then F into dx. Already I explained in differentiation concept. You will get more clarity how to do the differentiation. You can follow that. So this is about the work done. Now one more, not only this one, look here. Work done equals to force into displacement. Suppose they are giving mass into acceleration, MAS. All these cases theta is 0 degrees. Then instead of acceleration, we can write it change in velocity by time into displacement. But instead of displacement, we can write it average velocity. Average velocity is the sum of the quantities by number of quantities. Average velocity into time. Time cancel. Then work done equals to, you are getting half into m into, this is like v minus u into v plus u. V square minus u square. This is nothing but change in kinetic energy, our work energy theorem. So from this one more expression you got it. Change in kinetic energy also gives the work done. Suppose one body is there, that initial kinetic energy is the 10 joules and final kinetic energy is the 15 joules. What is the work done means, what do you say? 15 minus 10 equals to 5 joules is the work done. So from the expression from the kinetic energy also we can able to say about the work done. Not only this one, there are different cases to find out the work done. We are going through this one. Look here. See. One well is there, one bucket is there. Mass of the bucket is m. One rope is there, mass of the rope is m. This length is how much? L. One person is pulling this one. How much work done by the person? So here how many, what is that? Generally what we are taking, work done equals to force into displacement. But instead of force, weight we are taking. So mgl, what is that for first one, for bucket, plus rope mg into L by 2. Why we are taking center of gravity is acting at the exact that middle of that one, only till that we should do the work done. So that is mg L by 2. So this is the formula. If m equals to 10 kg, then small m equals to 2 kg. L equals to 2 meters. L equals to 2 meters. In this case, how to find out the work done? Work done by the applied force is plus work done by the gravitational force is negative. Why? In the case of gravitational force, angle is how much? This is the gravitational force and this is the applied, this is the body is going upwards. Here 180 degrees means at that time you can listen, read that question properly. By applied force means you will get positive, with respect to gravitational force it is negative. Then here work done equals to W equals to, look here, M is how much? 10 into G is the 10, this is the 2 plus this is 2 into 10 into L by 2 means 1. So finally our answer is 100 into 2, 200 plus 20, 220 joules. Like that we can calculate. Not only this one, we can, there are different cases to find out the work done. Suppose one container is there, one piston is there. Okay, here when you are applying the force due to the pressure, the volume is changing into delta V. So you can express that work done equals to pressure into change in volume. It should be right P into V2 minus V1. Generally we are using, this is in thermodynamics chapter, in the case of gases we are using. Not only this one, in previous chapter we discussed that this is the inclined plane when the body is coming from A to B. There you know that what is the acceleration? A equals to G into sine theta minus mu k cos theta. That is the rough inclined plane. Here this is the normal reaction, this is the mg cos theta and this is mg sin theta and this is the friction. In this case, how to find out the work done? See, mass into acceleration due to gravity, acceleration mu k cos theta into length of the inclined plane L. So like that we can find out the work done. This is from what? A to B. If the body is coming from B to A, at that time instead of minus you are getting the plus. Not only this one, in the case of simple pendulum, look here. We are taking one pendulum. It is lifted like that. How much height? Total length is how much? L. This height is, we are taking H, means this part is the L minus H. It will make an angle theta. This is the L. So in this case, how to find out the work done? From the figure, suppose this is OAB. OAB. Cos theta is how much? Adjacent is L minus H by hypotenuse is the L. From this L cos theta plus H equals to L. From this H equals to what? L into 1 minus cos theta. When you know the height, what is the work done? By the applied force, mass into acceleration due to gravity into height. But instead of height you can take it mg L into 1 minus cos theta. Like that you can take it. Suppose in this case m equals to 2 kgs, L equals to 1 meter and theta equals to 60 degrees. How much work done by this one means simply you can take it, mass is 2 into g is the 10, length is the 1 minus cos 60 is the 1 by 2, this is 1 by 2. After simplification you are getting the 10 joules. You are getting the 10 joules. Not only this one more condition is there. See, instead of the pendulum you can take one rod. You want to lift this one from here to here. How much height is there? This is the h and this is the L minus h, this is the L and this is the theta. Same thing here you are getting. The condition is mg L by 2 into 1 minus cos theta. Because here mass is concentrating here, we must take length of this one is till here. But in this case, gravity is acting at the center of the rod. That's why we should take it mg L by 2 into 1 minus cos theta. This one we should apply for, suppose one horizontal scale is there. You want to lift from here to here. So for this how much work done means mg into L by, suppose this is the length is L by 2 means you can take it mg L by 2. So it depends on the situation we can use the work done. Don't stick only one formula, force into displacement. And one more important concept I want to share with you, that is one chain is there. One chain is there, that is a part of that is hanging vertically, another part is on the horizontal table. Look here. One chain is there. Total length equals to L. Total mass equals to M. L by N part is hanging. L by N part is hanging. So each unit mass is how much? Total mass by total length. Now we want to bring this L by N also on the horizontal surface. Then what is the work done? Mass into acceleration due to gravity into height. So height, what mass what we are taking? M by L is the each unit. But how many units you require? L by units. G into that height is how much? L by 2n we are taking. Why we are taking 2n? Center of gravity, weight is acting here. Till here only we should apply the work done. So after simplification, work done is how much? mg L by 2n square. mg L by 2n square. So we do one problem also here. If m equals to 4 kgs, L equals to 4 meters, n equals to like 2. How much work is required to bring the chain like upwards means simply you can go through the work done equals to m into 10 into length is the 4 divided by 2 into n square is the 4. Is 4 cancel, 20 joules. 20 joules. Like that there are different conditions. Suppose this chain brings L by N1 to L by N2. Not entire that lift one. Just we are make some changes means here work done equals to mg L by 2 into 1 by N1 square minus 1 by N2 square. Like that we can change that one. So these formulas are all belongs to the work done. Then we are going to discuss about energy. What is the energy? The capacity to do work. The capacity to do work is called the energy. But in this chapter we are focusing on the two types of mechanical energies are there. One is the potential energy, another one is the kinetic energy. What is potential energy? The energy possessed by a body by virtue of its position. Like waterfall is there. So the water is coming from height to down due to the height difference. There the energy is possessed by due to its position, that is called the potential energy. Not only this one, you take one football and you press that. So whatever we are doing work, that is stored as a potential energy. One spring is there. When we are pressing that is stored as a potential energy. Finally the conclusion is the energy possessed by a body by virtue of its position is called the potential energy. Potential energy generally we are taking mass into acceleration due to gravity into height, and in the case of spring, half into k into x square. K is the force constant and x is the distance, like that you are taking. So this is belongs to the potential energy. It should be represent U equals to mgh also. But just now you know that dW equals to force into displacement is said. This is the general formula. So instead of W we are writing du equals to f dx. From this f equals to, we should write it du by dx. So the rate of change of energy with respect to displacement is giving the force. This is belongs to the potential energy. Like that, kinetic energy. What is the kinetic energy? The energy possessed by a body by virtue of its motion. What is a good example for that? Vehicles movement and river. Water in the river. Always it is in flowing condition, means that is having the kinetic energy. Formula for kinetic energy is Ke equals to half into m into v square. And here you should remember that relation between kinetic energy and momentum is Ke equals to p square by 2m. So from this, if m is constant, how can you give the relation between them? So Ke2 by Ke1 equals to P2 by P1 whole square. P2 by P1 whole square. Suppose we want P2 by P1 under root Ke2 by Ke1. If you want to find out the percentage error, both the sides you can take -1. After doing the simplification, delta P by P equals to under root Ke2 by Ke1 -1. Like that we can able to find out the percentage error also. Suppose they are giving, if error in momentum is percentage error in momentum is 2% and percentage error in mass is 1%. Find the percentage and the error of kinetic energy, means you can take power as a multiple. So 2 into 2 plus m is only 1%. After simplification we are getting that 5%. So this is belongs to the kinetic energy, potential energy and all this